Hello everyone, my name is Shivam Prasad and welcome to
So
my
you should
channel.
be very easy and
Today we
comfortable
have
for us
Vatsal
to
here.
for
He
him
is
to
the
lead
lead
us on
tech lead
this
from DYSON
trip
SPHERE.
to us.
And today he will be telling us the niche question like how do we really start with ML on TensorFlow? He has a wide experience of dealing with TensorFlow along with blockchain, DevOps, and all other technologies. Vatsal, you want to lead?
Yeah, hey Shubham. Very good morning, all of you. Both welcome you to our channel. And so, Shubham, what do you want to start with? So, do you have any question already in your mind?
Right, TensorFlow is like people care of it. People generally prefer PyTorch or Keras.
Mm-hmm.
We would love if you could tell us like how could we really start with TensorFlow? I mean, what should be the steps and why should we do it perhaps maybe? What is the best way to do approach it maybe?
Okay,
Then
okay. So, basically, you want to understand what are the basics of machine learning and how TensorFlow can help you achieve that, right?
right.
Okay, great. And I happen to have a presentation around with me, which I just used a couple of days back to showcase it to some other people. So I'll just use the same presentation here. All right.
Right.
Okay. And I have also shared this presentation on SlideShare, and it would be available for download. And the
Right. I'll
link,
put the link in description.
let me know, Shivam, when you are able to see my screen. Are you seeing my screen
Yeah,
now?
I can see a
Okay,
screen
cool.
now. Good.
Okay, cool. So, yeah, so machine learning with TensorFlow. This is the topic for today, right? And so who I am. Hello, I am Vatsal. Okay, I lead the technology team at Dyson Sphere. And our website is dysonspherelab.com. And we actually work on scalable technologies. We work on DevOps, we work on IoT, we work on blockchain, and we also work on machine learning. And you can contact me at vatsalm@dysonspherelab.com. All right, so on the right side is my picture while vacationing. All right, so the buzzwords. What is machine learning? What is artificial intelligence? What is deep learning? So I'll break down all these three buzzwords with you guys. So try to understand it this way. Machine learning is a very complex calculation or arithmetic done over a huge volume of data. Okay. Now this computation is done using certain algorithms and different algorithms are suitable for different kind of purposes. For example, there are regression problems, there are classification problems, etc., etc. So, what is artificial intelligence? Now, machine learning is rather dumb when we talk about artificial intelligence. Artificial intelligence takes multiple parameters under the consideration rather than machine learning. Machine learning does not just take one parameter, but it takes a single dimensionality of the parameters rather than artificial intelligence takes inputs from all over the place. So multiple machine learning algorithms combined together form artificial intelligence. And then you would ask, okay, then what is deep learning? So deep learning is a very special kind of artificial intelligence, which has been popularized by a very famous Google program called AlphaGo. So it uses, so they named their algorithm as DeepMind, and from that DeepMind naming, this deep learning term has been popularized in the industry of artificial intelligence. All right,
I
Shivam.
see.
So if you have any questions, you can always interrupt. Okay.
I see, yeah. So they're all interconnected. They're all the big branches, artificial intelligence. All these are subparts. Machine
True.
learning, deep learning.
True. True.
Mm-hmm.
True. So I was telling
Okay.
about AlphaGo, which was a special kind of artificial intelligence
Right.
software built to beat Go players. there is a very huge competition going on for a game called Go, and it is a Chinese-based game, and it is being considered the most complex kind of game to be ever played by a human being. And very not very recently, but in the recent past, the best Go player has been already beaten by AlphaMind, and then next version of AlphaMind has already beaten its previous version. So as you can see, deep learning has already evolved above human intelligence. Uh, but
Right.
but but not like human brains. It's just only for playing that game. Okay, right.
Hmm.
So let's moving on to next. So after clearing off those buzzwords, now we are talking about machine learning, how to get started in ML using TensorFlow, right? Okay, so basics of machine learning. I have decided to talk about 7 topics here for the basics of machine learning, and these are loss reduction or gradient descent. What are data sets? What are training sets and test sets? What is a validation set? What is feature engineering? Are there any good versus bad features? And how do we do data cleaning? All right. So let's moving on to our first thing, loss reduction or gradient descent. So any machine learning algorithm, what it what it tries to achieve, it actually tries to achieve minimum rate of error. Okay, and that is measured by root mean square error. So actually, we identified errors uh, doing a simple error loss function, like you know the exact value and you know the final outcome, and then you can just take the difference of it and you have your error, right? But when you are dealing with a large set of data, that error is not would not help you uh, uh, to get the bigger picture. For that, you find a root mean square for the error. What it does, it magnifies the errors in positive and negative spectrums. All right. So, so what we are doing is we are taking the mean. I mean, we are taking the root of all the means of squares of all the errors. So as you know, when we square a fraction, it becomes even bigger fraction. But when we square a bigger number, it becomes more bigger number. Are you getting it?
Right. So how do we apply this technique to machine learning problems?
So, okay. So what I was telling is a machine learning model tries to find the least lowest error possible. Okay. And the
Right.
way we measure this error is using this root mean square technique. Okay. Now let me come to gradient descent. So here, what you are seeing on the right side is a curve between loss and weight. Okay, value of weight. So as the weight increases, you are seeing how the loss first goes to a decrease and then starts suddenly increasing. Are you seeing it?
Right.
So
Right.
in this curve, there is a minimum point. I hope if I can. Is my mouse visible? So
Right. It
are you
has.
are you able to see this point is the
Yeah.
most minimum point in this curve, and that is where the loss is minimum for a particular weight value. Okay, so this at this point, I would say my model has performed the most accurate, right? So ideally, what we want is our model to always go and keep going down, down, down on the loss side. It should never increase. Okay, so this kind of graph is not a good outcome for a machine learning model. It should rather have truncated at this point, and that would have been a better model. Clear?
Uh-huh.
Do you have any
So that's
questions?
how we did. That's how we approach the problem. Okay.
All right. So let's moving on to data sets. So as in my previous, I told you that we try to find the minimum loss, but minimum loss on what? So we apply these machine learning on some kind of a data set, okay? And these data sets are generally in a huge number. For example, here you can see I have a data set of 19 million records, okay? So in this 19 million records, I have it's a SQL data set, and I have 5 columns here. Okay, so these
Right.
columns becomes my features. I would talk about features in my next section. But so what a data set contains is a structure or unstructured information which is used for feature modeling. Okay, so the machine learning is applied on a data set. If you don't have a data set, you cannot do any kind of a machine learning. All right.
Right.
Okay, so moving on to next part, what is training set and test set? So once we obtain the data, we have to divide that data into two unequal proportions. Okay, one is divided as a training set and one as a test set. So on the training set part of the data, and understand it very clearly, that training set and test set both have to be mutually exclusive. Okay, there should be no data which is part of both training set and test set. The reason being, first we run our model on the training set, and that is what trains the model. Okay, so basically machine learning models, while solving complex problems, they have their own memory where they keep storing, the previous outcomes. Okay, they uh, and that's how they do their best to predict the next outcome in a more better way. All right. So yeah.
So what is the proportion would you suggest for dividing the
Um,
data in?
if you're really beginning out, just do blind split of 70/30. That has been seen, that has seen the most, like favorable outcomes in general. In
Okay.
general, okay. So training set, once the data is model is trained, and the training happens over and over. Actually, later in the video, I will tell you there are certain parameters which you have to keep on adjusting, all right, while you are training the model. And once you are satisfied with the minimum loss value you have found in your in your training, correct? Then you leave the training set and you perform the same model on the test set, and that would what help you identify that the model has trained correctly or not. All right, so there are various ways in which model can misbehave. For example, there are two problems actually. One is overfitting, one is underfitting. Okay,
Okay.
I would talk about overfitting and underfitting also later, probably
Right.
in just next section. All right, so you understood we have to divide the data in training set and the test set.
Mm-hmm.
So moving on to validation set. Now, training set and test sets are good, but if you are doing the same exercise again and again over the same data set, the model tends to, as I told, have its own memory through which it guesses the next outcome in more appropriate or in a more better ways. All right. So what validation set does here is we first, as usual, train the model on the training set, okay? But after we are confirmed on the training set, we perform a validation on set, all right? And then and if we find that there is a discrepancy in validation set, then we go back to training set, we train it over and over again, then we come back to validation set. And after we have made sure that on validation set also model is performing correctly, then we do just one test on the final test set. Okay, so this is basically to avoid the problem of overfitting. Now, what is overfitting? As I'm telling you again and again, when you do the same kind of, when you run the model through same data over and over and over again, all right, so it would memorize the features for each model, each data, okay, and then it's like it didn't learn anything new. Okay, so overfitting is basically the model is not learning anything new. It is just performing on the same data set. But if you put the same model in a different kind of data set, it would fail miserably because the model has not learned it. You're getting the point? And this
Yeah,
is
I
what
see.
I use.
Right.
Okay.
So what is the
You have
proportion would you suggest for validation set?
For validation set, actually, in the last video I told you, training set, if you are considering 70, then combine both validation and test. You can make
Oh,
30, so maybe
combined 30. Okay.
15, 15, something like that. Okay.
Right.
All right. So moving on to feature engineering. Now, as I told in my this data set section that we have a data and then each column is a feature, right? But every feature, every column value is not exactly a feature. Okay, we need to convert it into certain notation which can be used inside the machine learning training. All right. So, for example, if you see here in this part of the so by the way, there are two images. One is this and one is this. Okay. Right now,
Mm-hmm.
I'm explaining this one. So you have a raw data which has some key and value pairs. All right. But then you cannot use this information as it is, like house info is an object. And in that object, you have num rooms 6, num bedrooms 3, street name, blah, 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 right? So all these values have to be converted in some sort of a form which can be processed easily, and the most favorable unit is numerical numbers, and that too, tried, it is tried best to keep the range between -1 and +1 or 0 to 1. Okay, we don't try to feature the column values to huge large numbers unless it is really really important. Okay, because working with the smaller numbers is much easier than working with the big numbers, which tend to increase the complexity inside the computation. So right, machine learning generally uses GPU power, and if you have more complex arithmetic operation to perform, it will utilize more GPU power. Are you getting the point?
Right. Right.
Okay, so here I told you a very simple way of converting some data columns into some features, and there is a one special technique used, which is called one-hot encoding. Okay, what this technique is talking about here is, for example, in your whole data set, you are only concerned about a particular value, which is shorebird way. Okay, so for a street name, you're just concerned about shorebird way, and you kind of tend to ignore any other value. For example, to your machine learning model, you're trying to predict if any house is belonging to this street or not. Okay, that can be example scenario. In that case, for one hot encoding, what you would do is everywhere shorebird way is coming for the street name would be value as 1, and rest all kinds of street names will become as value 0. So this way you would give the preference only to the street name of Shorebird Way, and you would ignore all other street, because your problem is to find which house is situated in Shorebird Way. And you don't want, if let's say the outcome is house is located in Lincoln Street, but you don't care about Lincoln Street, right? You just want to know, does
Right.
a house exist in Shorebird Way or not? Okay, so that is a technique which is called one hot encoding that can be used. There are
Right.
more advanced techniques, but in this video I cannot explain like many of them at once. Okay,
I understand. I
do you
understand.
have any questions?
So can like the size can be different, right, for every feature that one hot
Yeah,
encoding. That'll depend on how many features kind of subtypes we have.
yeah,
Like only we have 10 street name, then the size will be 10, I suppose, right?
yeah, true. Yeah.
Right.
Okay.
Okay.
So moving on to good features versus bad features. So after we have converted our data columns to features, then there are certain, I would say, rules, okay, or certain norms. If you follow, then you would tend to have your model performing better than otherwise. All right. So there are many ways. So let's say you have a information for house type. Okay. Now, in your database, you might be storing those house types with certain IDs. All right. or it can have a name. Now, the most preferable choice would be here as a name. Why is that? Because when you would see the outcome, or if you have to debug the process at certain stage, you would see this value and you would know what the model is doing. Okay, so although it is not easy to identify how model really works, but the how the how the values which are used for the input can give you a huge hint of if your model is moving in the right direction or not. Okay,
Mm.
so same way. So here a house age years, you are storing in year format and you are storing in second format. Now, if you're storing the data in year format, then it is easily consumable by you as a human, right? That okay, it is talking about 27 years. But if it gives you a second format like that, then I mean, it would take a long time for you to guess that what's going on inside this house age value. Yeah.
Yes,
Now,
yes.
the third thing which is to be avoided is this is called magical outcomes. I mean, something like that. Why it is? See, sometimes in our database, we tend to store values like null, -1 for something which doesn't exist. Okay, and the same data, same feature value has been transformed into a machine learning data set or a feature, right? And so this kind of because as I told in my previous uh, section here, we tend to convert some features, I mean some column values into numerical values as a feature, right? Now,
Right.
if your some of the feature has -1 and which is corresponding to rather missing values, but these kind of values can get mixed with your feature value. So the information regarding the missing value and the information regarding negative outcomes, right? Negative values are getting mixed up. So in general, at best, we should avoid these kind of setting -1 or 0 or these kind of things for missing data. Does that make sense?
Right. So,
Okay. So yeah, next comes data cleaning. So oftentimes for a machine learning engineer, most of his job is actually dealing with data, you know. So
and
there is an alternative name for a machine learning engineer, and that is called data wrangler. I mean, it's an inside joke actually. Anyway, so the data which would come to you would have lot of issues. Okay, the data will not be in the way which you want. The data would have a lot of errors because it would be coming from certain systems, and the system have been taking a lot of inputs. So there are chances of human error, there are chances of machine errors, and so there could be a lot of error data also sitting in the system. Now here is an example. This example is actually the data set taken from certain years census. I don't exactly remember which census for the California city. Okay, so what this data set is telling, how many how many rooms were used by each person. Are you getting it? So
understandable. Yeah.
we have 0.000 to somewhere point 0.8. I don't know if it's point 0.8 or 8, sorry. But basically what I'm trying to tell you here is, you see, we are seeing, okay, how many rooms one person occupies in general, all right? But here, there are certain values which are telling one person is occupying 50 rooms, which practically is not so possible. Are you getting it? So that's why
Yes.
this long tail, which you can see here, is the result of all those error imports and machine errors which have happened while data inputs, and that's why this graph is fine, but rest of this is actually maybe most probably is error data. Okay,
Right.
so one easy fix is just take log. Okay, so we were finding the rooms per person by total rooms upon population. Okay, so actually this is the population and this is the total room. So majority of population lives somewhere between 0 to 4 rooms or 5 rooms something. But there are few population which is like almost 1% even 50 rooms. Anyway, so what we can do is we can take the log of the entire thing and that would reduce our scale. Okay, that is what log does, right? In the mathematics, if you take a log of a certain value or a certain range over a certain range, right, then the whole range would be shrinked, the scale would be shrinked. That is what you are seeing. So the values which were starting from somewhere 0 to like 55, those have shrunk to like 0 to 4 just because we have taken the log. Okay, and as you can see this curve has widened up, so all these values which were very near to each other have become a bit wider, so we have like a better graph here. You understanding it?
So it does not affect the machine learning performance for after taking the
No,
log, huh?
no, it actually,
Nice.
machine learning doesn't care if you're sending the data in this format or this format. And this is just so we can identify some bad data which is in the system and we can remove it. Okay. Now, as I told, this log operation was the easy fix. Okay. Now, second technique we can use is um, called a clipping. Yeah, it is data clipping. So what's happening here is we are only considering the data values till the 4, and if something exceeds beyond 4, as you can see here, this curve is going a little bit beyond the 4. So what we have done is we have done a hard boundary that any value which comes greater than 4 will be considered only as 4. Okay, so we
Right.
have clipped the data at that particular point, but we are still not ignoring the values. We are just telling any value which is greater than 4 is 4, and that also solves the purpose. Okay,
Right.
it's called clipping. Now another technique is called binning. Okay, so here the curve, which is not very clear, I can understand, is showing certain relationship of the population with the latitude. Okay, now with our real world experience, we know the latitudes are not related to each other like how a linear scale is. Okay, so for example, if you're moving from this latitude to this latitude, right, the relationship is not like how the relationship is from 0, 1, 2, or between fractions. Latitudes are rather discrete numbers, right? So what we do is we consider each range of latitude as a separate bin. Each line, I mean each section which you are seeing here is a different bin, and we are only taking the value. Okay, this value belongs to this bin, this value belongs to this bin, sorry, and these values belongs to this bin.
I see.
Okay,
Okay.
so what we did is, for example, here it's saying latitudes lesser than 32 and latitudes equal to 32 and latitudes lesser than 32. Okay,
Right.
okay, I cannot read because it's very blurry text, but here they have specified a range, and that is what being specified using these bars, and this technique is called binning. Okay, so shall we move on?
Definitely. Yes. All good.
Now, TensorFlow. So uh, here I have mentioned about these 7 points about basics of machine learning. So any machine learning process has to go through all these kind of process, all these kind of uh, you know um, in so any kind of machine learning, it doesn't matter which tool you use. You use R programming language or use TensorFlow or use to use some other Python library has to go through all of these processes. Okay. So now in this video, we are specifically talking about TensorFlow. So how does TensorFlow help you in achieving all these processes? Okay, and what else TensorFlow can do for you? Now, what is a TensorFlow is a computational framework for building machine learning models. So TensorFlow itself is a set of libraries or frameworks, okay? And it exposes some high level APIs, but also you have access to some lower level functions or APIs through which you can modify the outcomes which are given by high level APIs. And
Right. So,
Python runtime, okay, and that Python runtime integrates with C++ component of it. And
right.
as you know, C++ are the languages which can directly communicate with the hardware. So TensorFlow has to perform operations on CPUs, GPUs, and TPUs, which are tensor processing units. Okay. So to interact with these hardwares, TensorFlow has a C++ library, and on top of C++ library at the system or operating system level, we have Python. Okay. And on top of the Python, we have lower level TensorFlow functions. And on top of that, we have high level object oriented APIs for TensorFlow. Does it make sense?
Right. Right.
Okay. So now, so let's see a simple pseudocode of a TensorFlow. What we do is, so TF is a TensorFlow package available in Python, and we are importing TensorFlow class from TF or a function. Okay. So first step is we identify which classifier, or we identify what kind of problem we are solving. Are we solving a regression problem? Are we solving a classification problem? So in this case, we have used linear classifier, which is the name of the algorithm. Okay. So as I told you, TensorFlow exposes some higher level object-oriented APIs, and that is available through estimator. Okay, tf.estimator. So linear classifier is an algorithm pre-built for you, ready to use. All right, so you do tf.estimator, and then you have access to linear classifier, linear regressor, I mean, and all those different kind of algorithms.
Oh, so
Okay,
all they all come inside linear classifier. Okay.
yeah. So you pass on your feature columns, and that sets up your classifier. And then you define the train method on the classifier, which would take an input function, and then you have certain parameters which you can adjust. Here I've shown in the green steps. So these steps right now is suggesting after every 2000 steps, uh, certain event would happen, okay, within this input function. So after you have trained your model, you can use the same model to predict it. So the same classifier, see, in the first step, classifier has actually taken the input data. These feature columns are the actual data which are supposed to be consumed by the TensorFlow training method. Okay, and that's what holds inside this classifier variable. Okay, and then that classifier variable is called the train method, and which actually performs the model training. All right,
Right.
and now your model is trained, so you can use this model to predict the outcomes in different scenarios. You're getting my point? So for
Uh-huh.
that, you have a different predict input function. And when you pass this input function, you get the prediction outcomes. And again, this is a pseudo code. It is not the actual code how TensorFlow code looks, but these are the steps which are performed. Do you have
Okay.
any so far?
So just 4 lines, and we can have it like in pseudocode also, in real time code also. I can only imagine there can be so much more, right?
Yeah, and that's what you're going to see next. And this is how. So here it is a complete implementation of a TensorFlow, and so let me show you what's going on here. Okay, so as you can first of all understand, it's all Python code. Okay, And a lot of things here are, just for the brevity, you don't need to understand each and every line here, but I would tell you what are the big blocks or big chunks which are doing what. Okay, I mean, if anybody is interested in working on TensorFlow, obviously it's a coding framework, right? They have to understand Python, they have to understand
Right.
some advanced mathematics, they have to know
Correct.
some Python libraries like NumPy and Pandas, right? And and there are certain things which are applicable on these libraries which cannot be explained for TensorFlow because it is specific to those libraries. So you have to first learn the Python. You have to understand the whole Python. You have to understand each of these libraries, how they're used, right? And then you also have to understand how TensorFlow can be used in all of this. Anyway, so you can see this line which is equal to this one, import TensorFlow at TA
Right.
here. Okay, that plus we are importing bunch of other libraries, NumPy, Pandas, and we are just setting few configuration options just for the brevity. Okay, now here see, this is our actual data set, which is loaded as a pandas data frame. Okay, so again, pandas is another library, it has its own functions, but what it provides you are certain data frames. Okay, now we this read csv method is available in the pandas itself. What it can do is you can pass it a csv file. Okay, and you can define the separator, and it would convert that csv file into a data frame. You're getting the point?
Right. Right.
Okay, so we have California housing data frame here. Okay, and this is the data. Now, in this step, what we are doing is we are actually just shuffling all the values, sorry, all the rows present inside the data frame, because more often than not, when we are extracting the data directly from database or any other system, it could be sorted. Okay, it could have a sorting based on certain column. It could be sorted based on time. It could be sorted based on certain numerical parameters. Okay,
I see.
so it is very important that you first sort, sorry, not sort, but shuffle the data. So any sort of sorting which exists should go away. All right.
Right.
So now we have to define an input feature. Okay. This California housing data has lots of features. One of the feature it has is total rooms. And right now, what we are trying to identify is a, a relationship between total rooms and the median house value. So basically, the problem which we are trying to solve here is, does number of total rooms in a house matter or relate to the median house value? For example, if a house is having 4 rooms and a house is having 2 rooms, uh, does these values, uh, anyway affect the median house value of both the houses? Are you getting it?
Mm-hmm.
So what we are doing here is the total rooms input feature, we are converting it into an input feature. Again, we are using a standard TensorFlow method called so TF, as you know, is our original package in Python, and TF dot feature column is a standard function, and then we are defining this total rooms as a numeric column. Okay, so we have
Okay.
just given a meta value for a column name as it's a numeric. Now, second, we have defined a target. So, okay, let me go back and tell you again. So first we take our input feature, and then we tell what what kind of values this input feature has. In this case, we are considering this input feature to have numeric kind of values. Okay, this could be categorical values. For example, your year, sorry, your month, right? January, February, March. There is no relation between January and February other than February comes immediately after January, right?
Right.
But if we talk
Sequence.
about numbers, 5 is greater than 1, but February cannot, you cannot say February is greater than January, or or like April is less than February. Are you getting the point? There is no relationship between the order of those. Okay, so those are categorical values, and we are considering as numerical values. Clear?
Right, right.
Then we identify the target, so which tells us that what is the target against which we are checking with this input feature. Now, this is an optimizer. Okay, right now, whatever you are seeing here, there is nothing very specific going on here other than there are certain parameters or settings which can be altered. So, like learning rate right now it's taking a very small learning rate, which can be changed, which can be altered to see how the model would perform in different values of learning rate. Okay, so
Yep.
we have defined an optimizer. Now, here in this case, so in last case we were using an algorithm called linear classifier, but in this case we are using the algorithm called linear regressor, again available through tf.st estimator API. All right. So in our linear regressive variable, we are just configuring a linear regressive function which takes the feature column which we have defined here as a numeric total rooms and the optimizer which we have defined here. Okay. Does that
Okay.
now see?
Right, right.
Now basically what we are going to do is on this linear regressor. So if you remember the last section on this linear classifier which we were running the train method, right? And that's what we are doing here. On this linear regressor, we are calling linear regressor.train. Okay, but this train requires some parameters. One is input function, one are steps. If you see the parallel here, there is input function which we were just passing a name of a function here which was not defined in this case because it is a pseudo code. Okay, and then there was a step. Here is the same thing. Input function, we are passing the actual function this time, and then the step. Now this function is a lambda function. Okay,
Right,
again, the lambdas are something which are native to Python,
right.
and if you want to understand lambdas, it's better if you refer some Python documentation. Okay, so we take my input function, which is defined here. All right. Now in this my input function, we are passing two arguments, features and target. So the features which you loaded from here, okay? These features you pass and the target, okay? The targets which you have loaded. So so try to understand what is the relation, what is the linkage here. Now we take a feature, we define what kind of feature it is, we set a target, then when we define optimizer function, and then we call our algorithm. Algorithm takes two things. It takes what kind of column it is, not the actual column values, but what kind of column it is, which is here, and the optimizer. Okay. Now, when you train, you need to tell the actual feature from the data frame. Those values are passed in plus what is your target. Okay. So, so,
Okay.
so this goes here, this goes here, this goes here, and this goes here. You understanding?
Right.
Okay. Now in the input function, this is a very standard function you would see I mean, if you take this whole code and you copy paste it in your implementation, more or less it would be almost like same. Okay.
Right.
Uh, uh, I mean, you can change few things here and there, but the steps which are used. So first you extract. So as you know, we are sending all the values of the features and the targets, right? So here what we are doing is we are iterating over all the values, and then we are converting it to a dictionary. Okay, I mean again, this is a standard Python programming going on here, nothing very specific, but here you have data set. Okay, this data set is imported from TensorFlow. Okay.
Okay,
TensorFlow
that's the
defines the
API.
data. You have data set. Now, data set has a function from TensorFlow slices. So what it does is it takes your values, uh, okay, and then it slices them. And that is something very specific to TensorFlow, that it cannot work on entire data set at once. It needs to slice those data, and how it slices depends on the batch size here. And batch size has been passed by default as 1, and few other arguments, default arguments have been passed. So you slice it, you define what is the size of your slices using batch size, and then there are a few other implementation details here, like repeat for every num epoch, which is none, so there's effectively no repeat. And then you can again shuffle the sliced data set. Okay, it is just, right, when you're going to perform a magic, you do the shuffling of cards, and as many times as you do, the chances are it would give a random outcome. Okay, so here it checks if somebody wants the data to be shuffled again, then they perform the shuffle again, and then it just returns on the data set an iterator. Okay, make one shot iterator dot next. So what happens is, inside this function is a loop which gets called over and over and over and over again, and using that loop you can identify the loss value. Here I have not shown how to calculate the loss values out of the data present inside here, but uh, after you calculate the after you calculate the loss values, you can plot a curve, or you can list it down in some, in some output, where you can. So basically, as I told in my very first slide, we want to identify that the loss should be keep dropping off. Okay, and if
Correct
there is
set
a,
of parameters, huh?
yeah, and if there is a point where the loss has started climbing up, we should stop our learning there. We should stop our algorithm there. Okay, so that's what happened here. Inside this, you can keep logging your loss values, and at a certain point, when you see you have achieved the minimum loss value, you can break this function, right? And at that point in time, your model has trained. Okay.
Okay.
Do you have any questions? I mean, I'm sure you have a lot, but see, this is not to teach how to code in the TensorFlow. It is just for the people who are curious about what is TensorFlow, how it works. So it's
Great
just a
AIs.
it's just a trailer of the movie. And later, maybe in other videos, I can go and deep dive down and take separate TensorFlow components and start explaining them into details, right? But for now, for this particular video, I think that makes more sense. Okay,
Right.
guys. So thanks for watching this video. Thanks for taking the lecture or machine learning TensorFlow. I mean, machine learning with TensorFlow. Uh, mm, this.
Right, people, if you have any questions, they can put it down in the comments. We'll try to get back to you. And
Okay,
thank you a lot. Thanks a lot for your time and patience for watching this video. Thank you.
sure. Please like and subscribe. Bye bye.
Bye.